Let's look in more detail at configuring and doing some testing on an access control list on a router. And perhaps I didn't explain enough of some concepts. If you look at my drawing here, everything to the right of an imaginary line here, this belongs to a company I've just named my company. So this part here is the service network for my company. And a service network has typically servers that provide essential services, therefore the name. If you're going to have a web presence and you're going to do it yourself, I mean the company's going to do it itself, you have to register the IP numbers of 2 DNS servers that are authoritative for your company. So there's my 2 DNS servers. I'm assuming here that the company is going to do its own mail, and of course the web server. Now actually in the real world, depending on how big your company is, you may want to contract all this out. Bigger companies are going to do it themselves. But I also put in an FTP server. Most companies nowadays probably wouldn't need an FTP server. I put it in because that gives me another example of some service that you might need to allow for in an access control list. So that's the service network, and I also put a few computers of the internal my company network. Now you want to keep in mind here that there's a lot more computers here. This is just a representation. Now everything on the left hand side is the internet. Now this is all other networks that aren't my company network, the my company network. And again, I can't represent, I can't actually add to my drawing all the other networks. Now, Packet Tracer does come with a cloud that represents the whole entirety of the internet. But I wanted some specific computers here that I could use for testing purposes for my ACL. So that's why I drew it out like this. So this part here is the 2754.72.0 network. The /24, that 24 tells me how many ones are in the subnet mask. So the /24 is equivalent to a subnet mask of 255.255.255.0. So although it looks like a Class A address because it starts with 27, it has been subnetted by manipulating the subnet mask to the equivalent of a Class C address. And again, this is mostly for testing purposes. Same thing goes down here. This is the, I didn't label this yet, this is the 6810.0/24 network. Same reasoning as we had up here. And again, I just put this on here and declared it a trusted network for the purposes of using it to test out the ACL that we're going to put on this my company border router. So let's look at some things here. Now I'm going to start off with no access control list on this border router. And if you once you put any one statement, even a single statement here, as part of an ACL, um, you've moved into the realm where you have to specify everything that gets through. So what I'm saying is, right now, I can go over here, and I'm just going to use, let's just use this one. I can go to the web browser here, and I guess I better check to see, yeah, DNS is set up properly. So let's look at how things are without an ACL. If I go to one of these workstations, let's pick this one, and I want to make sure that the config is set up right. I'm mainly interested in the DNS, the IP address of the configured DNS server. Now, I've pointed this out to you before. DNS in Packet Tracer is an abbreviated version of what really happens on the actual internet. For example, on the internet, if I'm sitting here and I want to hit the web server or access the web server there using its fully qualified domain name or its URL, my company, www.mycompany.com, first thing that's going to happen is this computer here is going to request the IP number that corresponds to www.mycompany.com, and it's going to get it from here, this DNS server that's configured to use. In the real world, the first thing that's checked for the IP address corresponding to www.mycompany.com is the local cache. Then it would go to the its local DNS server. If that server didn't know, didn't have it in its local cache, it would check first the root server, one of the root servers of the DNS system, and one of the root servers would provide the IP address of one of the .com servers, and then there'd be another packet sent to the .com server. It would provide the IP address of the two DNS servers that would be authoritative for mycompany.com, and finally this computer would get the IP number that it needs. So this is very much an abbreviated process, but it's going to work. Just keep in mind that it's abbreviated. So I'll go to the desktop here, and I'm going to go to www.mycompany.com. Click go, and shortly we're going to be shown the page. And of course, in the real world, it's going to be a lot quicker than this. So there's the page coming from the web server. Now keep in mind, this worked because right now there's no access control list here on the My Company border router. So what if we want to put an ACL in here? Well, again, as soon as you enter a single statement, you blocked everything except what you specifically allow. So well, always keep that in mind. Now, I was looking at how some of you were doing your testing of ACLs, the statements in the ACL here, and you were doing it one statement at a time. Well, that's probably okay. Well, it would be okay. But eventually, you have to put all the statements together, and you have to put them in the correct order. So here's what I'm saying. Now, this is just a little notepad. This part here, this will remove the access list that's there. This will go to the appropriate interface, which is the fast Ethernet 00 interface in this case. This assigns the access control list and also determines or specifies the direction. So here I've got three different possible rules, and I'm going to use this one because remember, if you're going to have a web server, it needs to be accessible from the internet. So look at what I've got here. This is the standard stuff, and now I've got a statement that says permit TCP any, and this means any computer on the internet. Okay. Some of you, when you were doing your rules, just picked out this particular network, and that's okay if that's what you want to do. But if you want to give access to the whole internet, you need to use something, and it happens so often that Cisco provided a shortcut method here. So this is any computer on the internet. So we're going to allow a TCP packet from any computer on the internet to go to the specific host that's using the IP address 202.70.112.14, which is the web server, as long as that packet is destined for the www service, which is actually port 80, TCP port 80. So that's a very rudimentary access control list. And remember, that's not going to be, well, you'll see in a moment, that's not going to be enough. We need more than one statement. So let's go here, and I need to be at the config terminal level. And now if I paste this in and press enter, now I've got an access control list turned on, but it only has that single statement. So now let's go back here, same computer, and I want to close this and reopen it just to make sure there's nothing vestigial there. So same thing we tried a while ago, press go. Now, I'm expecting this to fail. And when it fails, I'll tell you why. By the way, I think I mentioned somewhere when if I were testing this out, I wouldn't worry about using the simulation mode unless something didn't make sense. And I wish this would go on and fail. That would speed things up. So finally we get a message that says host name unresolved. And that's why I knew it was going to fail, because if you recall our ACL here, I basically said from any computer on the internet allow TCP traffic to the web server. I didn't allow traffic DNS queries to go to either of my DNS servers. So when I tried to access this web server using its URL, it's going to fail because this computer here, this guy here, doesn't have the IP number. So therefore cannot address the packets, and it's not going to work. Just to show you what I was talking about, let's go back to here, and I'm going to enter the IP number. notice this time it goes right through, because once this computer has the IP number, it can address the packets. And we have this rule here that says from any computer on the internet, if it's going to this host and it's has a destination TCP port of 80, let it through. And by the way, this is a good troubleshooting tip. If you can remember the IP address of an external web server, it's good troubleshooting. I'll tell you about that some other time. So, what next? Well, let's see if we can make this work with the URL. So we're going to need another statement here, and I happen to have one here that I think will work. So I'm going to copy that and put it right here. And this is going to be my new ACL. And now let's go back over here. And I think I maybe will paste it now. www.mycompany.com. Probably should have done this. Open it back up so you can see. So now it works because I added that rule that allows UDP packets from any computer on the internet to go to this particular machine as long as it's using UDP port 53, which most DNS queries use. Now typically we also turn on TCP port 53. Certainly UDP 53. Now, one of the requirements that I added, just to give you some help or some experience, is I said we want to restrict this computer here from accessing the web server. So let's look at how this would happen. So here's a statement that says deny a TCP packet from 681060, which is that computer there, if it's going to the web server. Okay, well, let's try that. Copy. Put it right up there. So notice now I'm up to three statements that I added in my ACL. There's always an implicit deny all at the end. Paste that in and execute it. So now let's go here and test this out. Desktop, browser. So it actually worked. Now we thought we had added a statement here that's going to keep this particular computer here from accessing the web server. I mean, there it is right there. That should work, shouldn't it? Looks good to me. But here's the problem. The way these access control lists work is just like rules on a firewall. The router will start evaluating a packet that comes in against this rule base. Well, the first thing it sees is if it's from the internet and it's going to the web server, let it through. So what we just did matched this rule, so the router never got down to here. So here's what we need to do. And remember, with firewalls and with access control lists and routers, order matters. So I'm going to put that statement up at the beginning. And now let's try that. And we'll go back and try it. Now, before I do, I want to remind you of something. That is the access control list. Okay, I'm up to 3 statements so far. This is just something that I'm using with Packet Tracer. Actually, in the real world, if you were doing this from a console directly into the router, which you can do, you'd have to do this here as well. Best thing to do is remove the previous list and start over. Because if you just add a statement to this, it goes at the bottom, and that may not be what you want. And while I'm thinking about it, yes, you can, in Packet Tracer, set up an example network of what you want to happen on your real router and test out your rules, and then from a console cut and paste into the router. It looks just like this. So you can test it out in Packet Tracer and then paste it into a real router. That works just fine. But anyway, let's try our new order here. So I'm going to copy this so I don't have to type it again. I'm going to kill this, open it back up, paste, and now go. Now it's going to fail this time because we changed the order of our rules. And see, we get a request timeout. Let's look back over here. I'm going to go down a level and do a show access list. And notice we've got some matches on our failure here. Probably should clear all this out. But this is actually showing you that it's working if you do a show access list. So order matters. And that's what I say. I noticed that several of you were testing one statement at a time and you didn't bother to put them all together. And I think you'll find that when you put them together, they may not work like you think they're going to work because you didn't put them together in the correct order. So here's what I want you to take from all this. Typically, an access control list has more than one rule or more than one entry. And while it's okay to do some testing 1 line or 2 lines at a time, ultimately you have to put it all together. And then you have to start worrying about the order that you have your statements entered. Another thing that I've noticed, several of you say, well, I went to this computer and I pinged the DNS server. Well, that's not going to do you any good because, although I didn't tell you this, one of the things you should do here is block ICOMP packets. So, and even if you don't block ICOMP here, whether you can ping to here doesn't really tell you whether the DNS works, if the DNS packets are getting through, because ICOMP doesn't use TCP, it doesn't use UDP. So pinging is often good to establish basic wiring is functioning properly. Although it's not conclusive because I can block ICOMP packets, and you should, by the way. Really, to properly test a rule, you have to go and use the protocol that the rule concerns. Like right here on this web server, I actually opened up a web browser. Okay, now the DNS is kind of implied because if I say www.mycompany.com, that has to be resolved to an IP number, and that's what DNS does. By the same token, If I open up in the just a browser, not browser, but a command prompt window, and open up the FTP application that you can run from the command prompt. If I FTP mycompany.com, it has to get resolved through the DNS servers. If I just put in FTP and use this address, it's going to bypass the DNS servers. So you need to use the real protocol. Well, you need to use an application that uses the protocol that you're interested in, whether your rule works or not. So if you want Bob to check his mail, you have to enable the border router to pass TCP packets with the proper protocol, and I'm not going to tell you what the number is, to get to these mail servers. You can't just ping. That's not telling you anything. So think about all these things. ACLs are more than one statement. Order matters, and even if you test one statement at a time, you have to put them together and then retest to make sure you got the order correct, because I just proved to you that order matters. And again, if you're trying to check out whether a packet to a web server goes through, you have to use a web browser. So keep all these things in mind as you work on any assignment, either in class or in the real world, where you have to configure an access control list for a router. And this is the same concept on a firewall.